Good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Endeavors. Okay, so in the previous class, we have talked about displacement and distance, and in the end, we have given a numerical problem to solve for you. I think all of you have to solve the problem. So today we will be discussing about the solution. So I think all of you have noted down the problem that was given in the last lecture class. Okay, so what is the problem given? So if you have understood the concept of distance and displacement properly, then definitely you can solve the problem without any difficulty. So the problem was given something like this, that there is a circular track. Okay, there is a circular track. The radius of this track, I think, was mentioned as half kilometer. Okay, the radius of this track was mentioned as half kilometer. Fine. So this is the center, and from the center of the track, the radius is half kilometer. Okay, radius is half kilometer. Fine. So the question asked was that if an athlete starts from this point, okay, starts from this point, this is the starting point, and just runs half the circle, okay, and reaches this point here. This is the end point. Okay, this is the end point here. Then the question was that what will be the displacement and distance traveled by the athlete on completing this half round around the track. Okay. So first of all, if you just consider what is the distance traveled by the athlete, so I think actually you have all noticed that distance is the actual path traveled by the person, okay, while moving. So here actually the person has traveled half of the circumference of the circular track. This is the, if I consider this is a circular track, so this is the half of the circumference, isn't it? So if I solve for the distance, okay, so distance will be nothing but, we know that the circumference of a circle is 2 pi r. So here it will be basically 2 pi r by 2, that is equivalent to pi into r, and as the distance or the radius was given to be half kilometer, so if I consider the value of pi to be 3.14, then it must be 3.14 into half, that is equals to 1 point, I think it should be 1.57 kilometer, isn't it? So this is the answer. Okay, this is the distance traveled by the athlete. Distance traveled. Okay. I think the board is not visible. Okay, now it is visible. Fine. So the distance traveled is 1.57 kilometer. And if I consider the displacement, so this is the distance, the first part. Okay, the second part is the displacement. Okay, so displacement is the shortest, as you have already understood that displacement is the shortest path between the starting and the end point. So if I consider shortest path, obviously it will be the straight line joining these two positions, isn't it? Joining these two positions, isn't it? So this is the actual the displacement, isn't it? So basically displacement is nothing but the radius of the circular track. So displacement is nothing but is equal to radius, that means it should be 2r, or it is equal to 2 into half, that is equals to 1 kilometer. So we have discussed in the previous class that displacement will be always less or at the most can be equal to the distance, not more than the distance. So obviously our calculation is okay, as because you can see that it is already the displacement is 1 kilometer, whereas the distance traveled is 1.57 kilometer. Okay, fine. So this is the distance and displacement. Okay, fine. So I think the concept of displacement and distance is clear to all of you. Now we will be moving on to the next topic. So we will be discussing about speed and velocity. Again, so speed and velocity, many of you must be thinking that speed and velocity basically are two similar things, isn't it? Many of you must be thinking that speed and velocity are nothing but two similar things, and because speed and velocity you have seen in a math book or many other books where speed and velocity are actually written synonymously, okay? But in physics, actually speed and velocity are two different things. These are not the two same things, they are two different concepts. Okay, so first of all, let us come to the topic of speed. Okay, let us come to the topic of speed. So what is speed? Okay. Now, giving it the definition of speed, it is defined as the rate of change of distance. Okay, rate of change of distance is speed. Nothing but rate of change of distance. Simply, rate of change of distance is regarded as speed. Okay. So when you are moving, actually, what do you mean by rate of change? When you are moving, you are walking, or you are running, or you are traveling by bike, or maybe any other vehicle, the distance that you are covering certain distance, and it requires some time. So if you just consider how much distance you have covered in unit time, that is basically the rate. Okay. So when you say that what is the rate of apple, you say 100 rupees per kilo. So per kilo, okay, you are considering the unit basis, that is rate. So when I consider rate of change of distance, it is nothing but the speed. It is actually the distance traveled in a certain time by the time interval. So I can definitely write the formula as the so distance traveled okay, by time taken. Distance traveled by time taken. Okay, so this is the formula for speed, right? So I think the concept is clear. Okay, now as we have already learned that distance, so can you tell me that distance is a scalar quantity or a vector quantity? I think everybody of you can remember or just recognize that yes, distance is a scalar quantity. So when you are dividing in scalar quantity by time, the quantity that you get is also a scalar quantity. So if I just consider that speed, so speed is nothing but a scalar quantity. So this is a scalar quantity. So while describing speed, it is enough to just tell about the magnitude and the unit. We don't need to know anything specific about the direction. So this is speed. Okay. Now, while talking of speed, we will be discussing certain types of speed. Okay. So let us discuss one by one. First, let us come to the fact what is uniform speed. Okay. So let us discuss first what is uniform speed. So one is uniform speed. We will be discussing one by one these terms. Uniform speed. Okay. So what is uniform speed? Now see, often when you are traveling in a car or a bike, you see that the speedometer. Okay, you know what is speedometer? Speedometer is the meter that shows the speed of the vehicle moving. Okay, when you are traveling in a car or bike and you are just moving on a empty road, or rather not so congested road, often you see that the speedometer is constantly showing a speed of say 50 km per hour or 40 km per hour. Okay, and you can see that the speedometer is constantly showing the speed for a certain interval of time. So I can say that the speed of that body within that interval of time is uniform. Okay, is uniform. So this is the rather simpler way to describe the uniform speed. So what does it actually mean? It means that the speed of the body is not changing within that specified time period. It may change after say half an hour, but we are considering that particular half an hour period during which we are actually observing the speedometer, and it is showing constantly 40 km per hour. So that is actually the uniform speed. Okay. In other words, you can also say that when a body is traveling with uniform speed, I can also say that the body is covering equal distances in equal time intervals. This can be also the definition of uniform speed. Okay. Just if you want to just if you are just going over your head, please write it down. Once you write it down in your copy and see it, it will be easier for you to just grasp it in your mind. Okay. So uniform speed can also be defined as when a body is traveling in same distances in same intervals of time, then that body is said to be uniform speed. Okay, this is actually the definition, book's definition. Okay, fine. Next, the second point that you come is the non-uniform speed. You just add a non, the word non. Okay, non-uniform speed. Now what is this non-uniform speed? What is this non-uniform speed? Okay, can you guess? I think many of you have guessed it, that non-uniform speed, when you say non-uniform speed, that means you are looking at the speedometer for a certain period of time, say half an hour time interval, and you see that the speedometer and the road is not so empty, okay, it's quite congested road. So at a time you are seeing that this speed is say 40 km per hour, after 5 minutes say it is 50 km per hour, then after again say 10 minutes it comes to 30 km per hour. So it is varying like this. Okay, now if the speedometer is showing such speeds which is varying in nature, which is not the same throughout that time period, then the speed is said to be non-uniform or variable over that particular time frame. In other words, you can also say that if the body does not cover equal distance in equal time intervals, the body does not cover equal distances in equal time intervals, then that can be also regarded as non-uniform speed or variable speed. Okay, so the definition of non-uniform speed or variable speed is clear. Okay, so uniform is when the body covers equal distance in equal time interval. Non-uniform is when the body covers unequal distances in equal time intervals. So that is regarded as non-uniform or variable speed. Okay, now next thing that comes is when a body is actually moving with non-uniform speed, it means that the body is actually, the speed of the body is actually varying, isn't it? And if you look at the speedometer, it will sometimes show 50 km, sometimes show 30 km, sometimes show 80 km per hour speed. Okay, so it will be varying like this. Now when the speed is actually varying like this, what is say that in such condition, under such condition, if you just look at the speedometer at a certain instant, very small time interval, say you are considering a 1 hour journey period and you are looking at the speedometer for just a time frame of say 5 seconds or say 10 seconds, and for that time frame the speed that you see or observe, okay, in the speedometer can be regarded as instantaneous speed. And this actually instantaneous speed, the concept of instantaneous speed arises when the body is having a variable speed, non-uniform speed. Okay, then that body will be said to have instantaneous speed, because the body is actually speed is varying, and over the instance, if you see for the first 10 seconds you will be seeing it as say 30 km per hour, then after say some time, after a time interval, you again see for 5 seconds you see the speed is 80 km per hour. So it is varying. So that speed at that very instant when you are observing the speedometer is called or is said to be instantaneous speed. So instantaneous speed basically can be said to be the distance covered by the body in a very short or very small time interval. So just please note it down, that instantaneous speed can be regarded as that speed when the body the instant can be defined as the distance traveled by the body in a very short span of time. That can be regarded as instantaneous speed, or instant, at any instant you are saying instantaneous speed. Okay, so these are the concept of instantaneous speed. Okay, so I think the concept is clear. Fine. Now the next thing that we actually skipped or you have not said, can you guess what is the SI unit for speed? Yes, definitely. I think you have guessed it right. You know that distance traveled in SI unit is meter, isn't it? Meter, and the time taken is actually second, isn't it? So when you are considering this SI unit of speed, it is nothing but what it is, meter per second or meter second inverse. It is the SI unit of speed. And if you consider the CGS unit, so SI unit is meter second inverse and CGS unit is centimeter second inverse. Okay, so these are the two units of speed. Okay, so I think the concept of speed is clear. Fine. Now, so we have discussed about the topic of speed. Today we will be ending our lecture here. In the next class we will be discussing about velocity and acceleration. Okay, so till the next class, please do study well and watch the video carefully. If you have any query, any doubt, please do mention it in the comment section. We will be happy to solve your problem, and please do like our videos or share our videos, so that all the students like you who are who needs this kind of videos will definitely help them. Okay, so with that we end our video today. Thank you for watching. Thank you. Goodbye.